Oh, good. Alright. Cut that out, cut that out. Okay. Hi, everybody. Um, so, what the fuck happened? The power went out. I had to go get lunch, and I was just really exhausted by the end of it. And I haven't made any progress. It's also really hot in my room, and I can barely do anything to fix it. I have 4 problems left. I want to finish them quickly and then move on to chemistry, because I think I've been doing this for way too long. So, here they're asking to find the direction, cosine and direction angles of the vector. So, I want to take a look at what my notes had said. Okay, so it appears that they use this equation. Cosine of, right here, right, the main one being cosine of over, I don't want to write this down. So, we have cosine of okay, so cosine of A over A and then A being straight up just the vector itself, so like A1. So, knowing that, we're going to try to apply it. So if we have the vectors of 2, 1, and 5, and we're looking for cosine of A, so this would be A, B, C, or A, B, and then whatever that symbol is, right? A, B, B, A, B, Y. We have the magnitude of, is it the magnitude of all of it, or just... Okay, it is a magnitude. So the magnitude A is 2 to the power of 2 is 4 plus 1 plus 25, and that is 5, that's 30, for 30.
John!
Yeah.
What you doing?
I'm recording so everyone hears
Oh,
you.
sorry.
Let's go to 10. I want to simplify this because I always have a hard time simplifying it. I think I can't. Nine, 8. Yeah, I think that's it. I don't think I can simplify that. But knowing that, right, we have now a, so it'd be technically 2 square root of 30. And then 1 over 30. And then 25 over square root of 30. And all of these are going to be under cosine theta. Alright. Let's try with the first one. So 1. Give me the angles to correct your centigrade. I'm gonna do, so here it gives me 68.6. Oh, it says 10th. You're really happy if it's correct. No, it's not. Yeah, I'm not sure. Four squared. Let's see. Square root 30 reduced. Yeah, it cannot be reduced. Okay, so that part's correct. Maybe it's this part. Maybe it's a complex fraction, so I can reduce it. So 2 square root of 30, square root of 30, square root of 30, with 30. It'd be 2 over 900 over 30. And then 2 divided by 900. Or square root of 30 over 450. That seems way too damn high. Maybe 89 point 3. No. Okay, I'm gonna watch it, see if I missed anything. Oh, is that where I messed up? They just 67? I feel so dumb checking this. No, I'm right. What the hell? See what I mean? Like, this is why I hate web assignments. I always end up using fucking chat. Because it's like, I don't know what I did wrong. And it's sometimes really annoying. Fucking hell. This is actually annoying. Okay. I had it in the wrong mode? There's no way that's the reason. No, 68.6. Is that not what I put? Yeah, I don't know what it could be. Even chat is like, what the hell? Oh, I know what I did wrong. I feel that's the angles. I'm an idiot. I know what I did wrong. Okay, so because we're supposed to do cosine inverse of to find what the angle is, to find out what A is, it's asking it on this side. So 68.6 would be here. Okay, there we go. I know what I did wrong. Edit. Asking for the full answer. Give the direction and direction angles correct to the nearest degree. Can I write this the full thing? Right, 1 over. Okay, and then this would be 1 over square root of 30. All the same thing. 25 over square root of 30. This is music. Did it change? I'm playing it on YouTube instead. And I think YouTube might have like a better one. No, not this one. Specifically, Meme Maker. Oh. I'm recording. I'm just recording me doing homework. Okay. Hopefully, with the change in music, this feels a lot more sillier than anything. Anyways. Oh, this is wrong. 25? Wait, there's a... No, it's 5. I'm stupid. So, maybe my notes aren't the most cohesive. But hey, what can you do? What can you do? And then I just... I wish you guys can see... I don't know if I can. I wish you guys can see the calculator. 1. And then 5. But I have to input it because I forgot to change it back to radians. Okay, so 1 and 5. Wait, I realize you probably can't even hear the music. Oh my god, so many fucking shit open right now. Hold up. I was like, what the hell? And I realized that you guys can't even hear the music. Alright. Anyway, so it'd be 79.5. 24.1. Great job. And this is the exact same thing. It's the exact same thing, just a different angle. What a journey, guys. What a crazy thing to follow. I feel like the chemistry one is going to feel worse. Because I think, at least in math, you're like, I feel okay with being a little bit down, but like, with chemistry, I feel like it's just so much. Like, it feels worse. I don't know if that makes sense. Like, at least, like, you feel kind of out of your depth with chemistry. You know what I mean? I don't know. So, same thing. We do our magnitude. So, it'd be square root. I want to write this properly. So, A is square root of 4, negative 1, negative 4. And you get, square root. Square root of 4 is 16. 4 times 4 is 16. This is 1. This is also 16. 16 plus 16 is 32. Plus 1 is 33. I don't think I can reduce that. Yeah, I think I'm fine like that. And then we have our 4 over square root of 33 minus our negative 1 over square root of 33, and then our negative 4 over square root of 33. Can these be negative? That's a great question, John. I think they could. Let's see. Moment of truth. Damn it. Oh, I used the wrong number. Moment of truth. Okay, there we go. We're moving. What's it? Now we're moving. Let's get grooving. I can't. Excuse me, guys. I'm sorry. I had a Diet Pepsi before this. Actually, I think I might go get Diet Pepsi after this. I'm really thirsty. I have a thing where I have a habit of chewing on things. So I was like flossing and then I was chewing on the stick that it came with. It was not pretty. I actually might, what I'll also do is that and for those of you guys who cannot see, I'm doing this, right, basically, and then I'm gonna do cosine inverse. Cosine inverse of x. Right, that's basically what I'm doing. So, I'm putting that in my calculator. 4 square root of 33. 1 square root of 33. See, in retrospect, I don't think this should have taken me as long as it did. This is supposed to be, I realize, okay, before I make a mistake. So we have our 4 over square root of 33. We have 45.86. Actually, make that. Wait, nearest 10th. So it has to be 89. And then for the next one is negative 4. Or no. 134. .1, and then this is 100.0 because it's yeah, there's no rounding for that one. Whoa, wait a minute. Did I format it wrong? I wrote it like this, but I think I might. Can you guys see that? You guys can't see that. I just realized. Does this happen every time? Peekaboo. Not close enough. Anyways. I don't know. I don't know why it doesn't work. My profile, let's just go up. So like my my power went out and I like did not keep track of like everything kind of just disappeared. So I'm writing it out as -4 divided by 33 on my calculator. I don't think that's correct, though. So I'm going to try to rewrite it on here. This just became like a compilation of John not knowing how to use a calculator. I really don't. You know? Like, I think people tell you that they gotta you gotta learn how to use a calculator. And you're like, yeah, I'll learn. And then you never actually do. Like, you feel like you do, but then you don't. And then you see some of the stuff you would be doing, and I'm like copying and pasting. I'm like, what the hell? What's going on? Man, this is crazy, guys. Oh, I didn't have it. I have them inverted. Cosine B is 100. I didn't realize that. No, so I could have written it as it was. Never mind. As you were, I guess. $134. What I had. 0.1. Ayo! Fantastic, great. You guys like the aquarium going on, by the way? I'm a fan of it. Will I look back at it? But I think it looks pretty solid. I think it'll be a whiplash for people who like are like jumping from like back to back and they see it, but I don't think it'll be that big of a deal. This is oddly simple. I had this issue with last time. One of the other ones. I had a hard time because like some of the questions looked way too easy for what they were. Okay, never mind. I'll do this one and then I'll go get on a little water break. I have this little army one that I have by my side all the time. I ran out of water. In the most literal sense, I came back from 66 and I came back from 66 night market, right? Do you guys prefer if I do this? I think it'll look crowded though. I think it makes sense. I think it's like taking advantage of the lines. But look, actually it looks fine. Okay. So I came back from 66 night market. And I got home like I was super full, super thirsty. Because you know when you eat junk food you get really thirsty, right? I was really thirsty. So then I was like, oh, I'm gonna play some video games. I did not feel tired at all. So I was like, I'll play some video games. And I was like finishing the last of my like Overwatch 2 like support. Support isn't that magnitude, it's just dot product. Just in case I forget. Yeah, dot product should give us a scalar number. We learned that on the other video. 7. See what I mean? It's just like, oh, I did this trick, right? We have 10 fingers, right? And you got 1, 2, 3, 4, 5, 6, 7. It gives us 36. 36. Right, and then 9. That's right, 9 times 7. 63. Wait, no, I'm supposed to do it this way. 1, 2, 3, 4, 5, 6, 7. 63, right. 63. 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 63. Right? Is that backwards for you guys? That's basically what that is. I was like, there's no way it's 36. It's really low. Don't pay attention to me. And then 6 times 8 is 48. No, that's... Oh, what the hell? I know things? Who would have guessed? 63 minus 48 is 15. And that should be it, right? Let's see. 15. Okay, so what I'm gonna do now, I'm gonna go have something to drink. I'll go fill my water over. I'll be right back. Yeah, I don't know. I don't know how to show you guys while. My hair is all weird. We'll focus on that for now. Oh, here's what I'll do. I'll do this. Look. And then I'll do scene. Okay, so the mic should be coming through. It should be the same. And then I keep. Where is this? I know you guys are getting blessed. I'm so sorry. It's literally just me learning how to do this. Can you guys? Okay, you guys still hear me. I'm gonna lock that. Oh, yeah, it's hard. Okay. Okay, I'll toss that. Okay. I know it's not working. I had a video capture. Can I copy? No. And then what I'll do, I'll delete all of this. Look at that. Okay, and then If I delete this, it'll delete everything now. Oh my god. And the music's not even playing. Audio. I realized how loud that was. Oh my god. Okay, so I have audio, I have visual. I just... Ignore the void that is the left of me. Wait, can I add like a little display thing? Add text. BRB. I don't know what I am doing. BRB. I don't know. It looks so dumb. Anyways. Let's go! We did it! Okay. I'll be back. Okay, I'm back. I'm back, baby. Okay, so I was informed to put my volume down or quiet down. Which I had no idea. I thought it was fine. But I'll put it down to here. And then hopefully... Well, because I think my... Back over here. Okay. Yeah. No, my volume is that low. I'll keep it lower, but then I'll bring this down a little bit. There we go. I think I'm also just a loud person. Kind of just accepted that. Alright, so consider the triangle with a vector of this, this, and this, and this. Determine the following vectors. So, we know that a scalar, or if we go back to professor's notes, right? We want to know how to, I think that is melt vectors and how to, I don't know what that says. I have beef with the cursive. I learned how to do it when I was younger, did not like it. A friend, actually, who only reads cursive, I hate it. This is an abomination, and I hope I get over it really quickly because of my professor. In order to find a vector between... Oh, but it's different between three products. Let's see. Continuing. When the vector represents P vector, B, notated product, B definition. Okay, well, I'm watching the video then, because I don't think it's gonna be.
Vectors to decide whether the, so let's suppose here that is in, if I form the equal to 90 degrees, minus 3, that's 0 plus 3, which is a positive 1. Now we just need to see if PQ dotted with PR is 0. If it is, we're done. That means the angle there.
Wait, vectors decide whether, use vector decide whether the triangle, is this the same question? Oh, okay, consider the triangle with the vertices P0, negative 2, 0, Q, and R. Determine the following vectors.
At the vertex P is going to be a right angle. If it's not 0, we have to consider Q or R to try and find whether or not either of those angles.
Wait, how did he find?
P at 1, negative 3, negative 2. Q at 0.20, negative 4. And R at 6, negative 2, negative 5 is right angle. I'm not going to attempt to draw these points in R3, but I will go ahead and sketch out a triangle we are doing here. It's right angle, but use this illustration to help us decide which way to go. R3. Let's suppose we want to determine if the angle at the vertex P from P to Q and the vector from P to R. And I know that we'll have a right angle between these two vectors if equal to 90 degrees. Probably not happen. Now PQ, that's going to be in component form. The components of Q minus the components of P. So 2 minus 1.
Okay, so if I'm going from, I don't know how to explain this. Okay, so I get it. I think I hate that like GoodNotes does it the other way. I like GoodNotes, but I switched. So also, I don't like I could pay $20 for Notability. I'm trying it because they record my lectures a lot better than anything else. Okay, so if we have P, which equals 0, negative 2, and 0, we have Q, 1 minus 1, and R, which is 5, negative 1, and negative 3. We have those, and we're determining the following vectors. If we're going from Q to P, and because it's 3D plane, we have to go from final minus initial within their specific components. we're going from Q to P, that means final being P minus initial. So it'd be 0 minus 1. And then it'd be 1 minus 1 minus negative 2. And then negative 2 minus 0. That gives us 1 comma 3 comma negative 2. And let's see if we're correct, because I want to make sure that I'm correct, and I don't want to lie to you guys. You know what also kind of contributes to my thirstiness at the moment is the fact that I ate a chili dog for lunch. And I regret it immensely. I feel like shit. This leads me to believe that I had it backwards.
Triangle that is in R3. It looks like it may be equal angle between them. Now PQ, that's going to be in component form. The components of Q minus the components of P. So 2 minus 1, that's 1. 0 minus minus.
Okay, well, we'll word it how he words it. So, PQ, so 0 minus 1 is 1. P negative 2 minus 1 is negative 3. Oh, I wrote it backwards. See, here's why it's important. Components of PQ, so it'd be 0 minus 1. Oh! You get negative 2 minus 1. Then we get 0 minus negative 2. 0 minus negative 2 would just be positive 2? There you go. Okay, so yeah. I worded it wrong, and we're gonna try it again, because that's the whole point of this whole thing, right? So we have, now we're looking for QR code. Give me the QR code now. You know what my biggest gripes are? Menus always being on QR codes. I think it's too much work sometimes, and it's getting on my nerves. QR, so we have the component of R, so we have R minus Q. We have R minus Q, and then R minus Q. And that gives us 5 minus 1 is 4, negative 2, negative 3 plus 2 is negative 1. Our vectors are 4, negative 2. I'm so sleepy. I want to sleep really late. But how would we know if it's right-handed?
Third component is negative 2 and negative 3. So this go from P to Q, the coordinates of R and subtract the corresponding coordinates of Q, so 6 vectors we're going to take to 1. That's a negative 4 plus 3 times 2 is 6. And this is a right angle.
I don't want to think about it too hard, but okay. Okay, so we have a triangle with the vertices of that, and that. And we determine the vectors of how the individual vectors are moving. QR, then from QP, and then using QR and QP, we find what that final angle is. I think my question for this one is, does it have to be only one angle to go off? Then dot product. Because I'm curious, because I think that's a pattern I noticed. You have the QP and the QR. But then we also have the dot product with the QR and QP. So then, like, for example, you do negative 4 times negative 1 plus negative 3 times negative 2 plus 2 times negative 1. And we have negative 4 plus 6 plus negative 2. Now that over, we get 0. So we have 0 for that. Is this a right angle? I'm going to say yes. But I don't know why.
Minus 4, 1, 2 times. Say that the angle at vertex Q is in fact a right angle. And thus, this is a right angled triangle.
Oh, why though? I don't get it. Yeah, I don't know. I'd have to ask about it. If somebody asks about it in the comments, I'll definitely answer it. I think as of now, this is good. I like zoned out. Okay. Find the scalar and the vector projection of B onto A. What does that mean? I have no heckin' clue, man. So let's look at my notes again. You get the following formulas and scalar projection onto B of B onto A is component AB is equal to AB over the magnitude of A. A scalar. Vector projection of B onto A. Oh, they're different. Okay, so we will write that down because I will forget. I'm sure someone's looking at my notes and being like, John, these are fucking horrendous. Oh well, I'm almost done with my homework. At least with my math homework. Sometimes rant because I keep getting distracted by my phone. Gotta put it away. But sometimes I get suggestions of people on Instagram. I'm like, who the fuck are these people? And it's not even like it's complete strangers. I always see this thing like on like TikTok of like people cheating or like hitting people's DMs. Like, oh, I found you on my suggested. Instagram recommended me. I didn't get it until I started following people on Instagram, and then now all of a sudden I get a bunch of random recommendations. I'm like, what the hell is this? I don't know this person. Why would I follow them? That makes no sense. And I think about those moments. I'm like, damn, somebody got that suggested. We're like, damn, this person's attractive. I'm gonna hit my shot. But it's like, this person, you don't know this person. This person doesn't know you. And yes, there's that off chance where it's like, maybe you can get something out of it. But I'm like, the chances of that happening, I feel like, are so low that I don't think is that like feasible. I realize I keep looking at the fishes. Like I have my screen up here, or I have my camera up here, the screen right here. If I like look at this, I'm like what does it look like if I'm staring at it? Yeah, it just looks like I'm staring at it. Yeah, So, I keep getting distracted. Let's keep going. So we know that the equation for component B onto A, and I'm going to write that specifically. Component B onto A. So I know that component, and I have it BA, or I have it written out the other way. Oh, it's AB. Is equal to A dot B over A magnitude. And I know that additionally, there's another one, the projection of B project. It's a scalar, so that's what it is. Alright, so okay, the first one gives me a scalar. The second one gives me scalar. B onto A. No, I can do this. I don't know why I don't. It might look a little weird, but I could definitely do it. Hey, Mom. Put that over there.
Deberías de guardar para que el gato no lo tire.
No, it's not. I'm tired too. I have one problem away from finishing. I still have more homework, but at least math homework can be done. No more calc! I'm free! Let me take it out. Alright, enough homework. Enough. No napping on the job. Anyways. So, we have our equation. We did it, boys. So now that we have our equation, this is a vector, dot product. This is being multiplied. I did do a little. It's not what I was supposed to do. I'll do it like that. Okay, so we now know, and then I also have to specify this is for a vector. You know what vectors have? Both direction and magnitude. Oh yeah! I always want to do that during class because I'm always like, vector from Despicable Me. And I don't ever, and I mean ever, have the balls or the confidence to do it. But I really want to. ¿Qué pasó? ¿Qué pasó?
No, tenías prendido el aire.
Sí. Which I really want to. And I think it's the funniest thing ever. And then the thing that sucks is that if I laugh, if my professors say it. Like my chemistry professor said that one time, and I was like, oh, and he was like, oh yeah, and then this other girl who sat next to me, not next to me, but like near me, like she said it, responded full calm. She was like, oh yeah, every time he said the word vector. It was incredible. It's my favorite thing ever. And then my new professor, the one now, is when we're doing vectors as the first part of our Calculus 2 assignments, she mentions vectors all the time, and I have to fight here to say, oh yeah, because I think this class is dead. It's a 6. Like if I show you guys my schedule, class is from 6:45 to 12:15. It's a night class, not great. But it's been a journey, guys. It's been a journey. It's been a busy, really fucking busy, semester so far, and I'm on week 2. I got 2 weeks to study for a test. It's gonna be great. Anyways, the scalar projections of B onto A. Let's start with the scalar ones. We're gonna do it down here. I feel like you have more than enough space. Yeah. Scalar projections, do it down here. It'll be great. So we have component of A dot B over A. So let's find A. The magnitude of A is -5 square root of 5 squared plus 12 squared. This is 25 plus 144. That's the only one that I remember, because everybody thought they were so cool, kind of saying like, oh, 144, like they were like, oh, 12 times over 134. And then, in retrospect, it wasn't that cool. See, like, you know how smart I am? That is 13. So smart. Let's see, 169. I remember because it's a funny number. I also saw it a lot when I was doing like trig, because Trig did a lot of like weird numbers, specifically 13, like square root of 13. I don't know, weird. It's something to do with 13 squared. But yeah, so we have our magnitude. And we have the dot. Now you have to find the dot product, which is the dot B is equal to -15 times 4 plus 12 times 6. -20 plus 72. Clear. 72 minus 20 is 52. 52. So then our A dot B, right? Is it 52 over... So then our component of AB should be comp. I could be playing Overwatch. Okay, I think the more tired I'm getting, the more like unhinged I feel like I'm getting. There's no way that looks. That seems really low. And it probably is. There you have it. The dot product go up top? The dot product goes up top. What the hell? What are they doing? I'm gonna write, because of that, no, this is how I'm gonna punish me. A dot B over A. And that's gonna give us 52 over 13 or 4. Or 1, I guess. And that should be giving us our answer. I was like, there's no way it's 1/4. It seems like an insane number to have on it. Almost there, guys. Almost there. I feel like, because I'm getting towards that stretch. I also want to thank you guys for coming along with me on the journey. I feel like it's so much. There's a pressure of you guys watching me and like it being written documentation. Yeah, I didn't hear that. Written documentation that. Yeah, I talk like this now because I have very deep voice, very manly voice. Written documentation that I did my homework in a very manly manner, in a very like kind of concise manner, because I think a lot of times we get distracted by really small things, and the feeling that someone's watching me makes it so much worse to like procrastinate, because they're like, bro, what the hell, you're talking about how hard we're working. I can't see it, and what I do see is you slacking off with your tomfoolery. Bro, I'm not even done with the question. What am I doing? Anyways, before I move on like a fucking dweeb. See, now this is weird. So we know the dot product of A dot B is 52. So we got that. We went that far. Over the magnitude of A, 13 squared, which is basically (52 over 169). Oh, it's just 4 over 13. So we got that far. Times the vector that we are given. Oh, and you straight up just distribute. Straight up. I'm gonna just write that. Straight up distribute. So okay, but I also realized Yeah, I'll do it. And then if not, I'll worry about it. So we have 4 over 13 into the vector of A, which is negative 5, 12. And that becomes negative 5 times 4 over 13 and 4 times 12 over 13. 4 times 5. Negative 20 over 13. And then 4 times 12. 48 over. Actually, that's correct. I don't feel very confident. I have a feeling I did something wrong. You in the comments. That's wrong. That's wrong. Oh, let's go! It's not wrong. Let's go 100%. Want to hear a funny story about my Oh wait, I'll do. Nah, it's fine. Okay, so this, I'm done. I'm done. I can mark it off. It took me way too damn long to do it though. There we go. We did it. So I don't. Now time for chapter. So now we're moving on to chemistry. Let's go. I think as of now, I think I'm pretty different about chemistry. I don't know what music I should listen to. I feel like nostalgic music. Let's see, what is this? Let's see. What's a good one? Let's see. Live. Let's just switch it to live rainforest. Oh, wildlife forest? Can you hear anything? Okay, I'm going back to the soundtrack stuff, but I'm keeping the. Actually, I'm muting the audio for this. But I'm keeping the soundtrack stuff. Let's see. We'll go back. I'll even switch up the vibe here. Should I just go full dark? Where's the controller? I lost the controller. I found this thing. I don't even find it. I have it. Oh, my mom put something away. Let's see. Let's go full dark. Oh, that's not dark. Just go full like. Oh, it doesn't. There we go. Just go full like. But I feel like I have to do like lighting. How does that look right next to the blend in. Okay. There's some scary stuff. That's a good soundtrack. You know what? You know what I was listening to the other day to go to sleep? I I have this in my sleep playlist. And I'll explain the sleep playlist at some point. I just have to be asked about it. But specifically, I listen to this. And just that. Just that the whole time. And if I do like a little one. Okay, I'll be right back. I'll be right back. I'll let that play for now. Okay, I'm back. I'm back. Different vibes. Is this too creepy? I think it's because the live is like. It's I don't mind it because it's less stimulating. Hold up, I might go to movie theater. What's up? Yeah, I'm just recording.
Can I get the keys for your car?
Yeah, they're in my bag. They're outside.
In your little bag?
Yeah. All right, guys. I'm. Wait, hold up. In order to do this properly, I gotta. Oh wait, I'm still on it. Anyways, guys, I'm back. I'm back. You guys like the background music? It's very ominous. I don't know how loud it is compared to how loud I am, but I feel like the vibes are there. I feel. I was making plots. I don't know if you guys can see. I'm gonna watch Jaws. You cannot see. Anyways, I'm gonna go see Jaws in 40x. Because why not? Okay, so I have plot. I have to watch Jaws at 7. Currently, it's currently 1700, which is basically 5. But to watch Jaws at 7, that's in 2 hours. 2 hours means I have 2 hours to not just do my chemistry homework, but also set up my chemistry homework. Also, you guys fuck with this? You can tell me if you don't. I Yo, they got stuff there. I'm gonna pin this and then I'm gonna wham. See, it's the same website though. It's just great. I opened the wrong thing. No, it doesn't show. That's a weird way of like doing it. What if I just look up? up. Let's see what YouTube has in store. Alright, just like a background video. I don't know what to play or listen to. That's a crazy thing. Hmm.
Mande, tía.
Sí, Mateo echa la mano a tirar la basura.
Está abajo. Pero si quieres, no sé, si quieres tú.
I don't think I've ever. Oh, I haven't. Have I?
Do you wear shorts? I was gonna wear a tennis skirt, but
Well, wear it. Fuck it.
I'm literally
You're gonna fucking wear it.
I'd rather
Hans Zimmer did F1 is crazy.
I think one of those two. Oh, I found
Me
my.
gusta
I wanna
jugar.
play Baja
¿Has jugado? ¿Nunca has jugado pádel? Que es como tenis, pero toda está cerrada y le puedes pegar a la pared.
Like
Está
with your
bueno.
hand or with the paddle?
Con el paddle.
No, I've only played the one with the.
It's fucking good, dude.
You guys remember my mom's define jacket with my fajas and
So
skinny?
this is gonna be a little bit hard.
Not feeling Hans Zimmer right now.
Yeah.
Okay. But we only have two rackets. Oh, Brian,
Oh,
we
Except
might
don't
go.
have rackets.
He got two. He got two. We might go buy rackets for us and you. No,
Yeah,
Brian, I
he
don't
has
feel like
a
it.
purple racket. Is that the color of the helmet?
He only has two.
And one's
That's it.
purple though. And one's pink.
Chiquito. No.
John!
What's up?
Are you still
Yes.
okay? Well, do you
Bye.
have
What's up?
you have two tennis rackets, no?
Yeah.
And one's purple or pink? I know one's
One's
a girl.
pink.
One's pink.
Did you say one of them is a girl racket?
Yeah, girl.
Because
color.
they're pink?
Yes.
That's crazy.
I'm gonna wear.
Jack, clip that. No one's
I'm
watching.
gonna dress like a tennis player. You know, I'm really bad at tennis.
I
I'm gonna wear
mean,
a
most
big-
of tennis is just dressing like a tennis
Lululemon
player.
Duke jacket, and then I'm gonna wear a tennis skirt. I don't know what shoes I'm
Wait,
gonna
you
wear.
should get some sunglasses.
No.
Those
I
like
don't know
really
what shoes
fat
to wear.
ones.
I don't know what shoes to wear because I don't know.
I don't know what music. You might be thinking, John, you're spending way too much time doing yours. But I'm really big on this. Bro.
Ella sí quiere ser tenista. Así quiere ser.
Okay, we're gonna listen to the
Joe McEnroe. Fíjate, es el hijo del Kinga.
Elías sí, fue cuando ganó su. Y luego perdieron. Y ayer en el 15, haz cuenta que entró y estaban ganando.
Okay, yeah, so we're gonna listen to that for now. I'll put it down a little bit actually. I'm gonna put my volume down so I don't have to. It looks so dark in here. Oh my god. And then let's see if they have anything. I doubt it. Background video. Dinosaur. Can I have one that's not AI? Like, I guess it's a lot to ask. Oh, I wrote the wrong thing. Background forest video. How do I specify like dark forest? This one straight up just says forest. Like, can you guys see that? That's so funny. It's just straight up forest. Fourth Wing reading. One day I feel like I should read this to you guys because tale of a fucking. There we go. This is what we're looking for. And then hold up. Wait, turn it back on. Do I blend in? Am I one with It's not green enough. I guess not green enough. We're back, baby. I genuinely Oh, look at this, guys. Very cool. I got it from 66 Night Market. Okay, so back at it again. Once again, some might think, John, you're putting in way too much effort. You just wasted the last 15 minutes of your life trying to figure out the lighting for and the ambiance for your chemistry. Most of science is looking cool. Most of science is doing what you can to make sure that you look cool. Like, I don't know about you. I put on that lab coat. Aura, straight aura, and that's my goal. So, that being said, welcome to Gen Chem 2. Ladies and gentlemen. Okay. I did the first question already. To kind of get the general gist of how to do things. I might have a lot of questions. I might be lost. But it's what we're here for. It's what we're ready to do. 16 questions, 2 hours. Can we do it? Hey Alexa, set an alarm for 7 o'clock.
Good evening, John. Is that 7 o'clock in the morning or in the evening?
Actually, never mind. Scratch that. Actually, Alexa, set an alarm for 6:45 p.m. Alexa, Set an alarm for 6:45.
Is that 6:45 in the morning or in the evening?
In the evening, please.
Alarm set for 6:45 p.m.
We're ready! So you can't... This music is a lot more hopeful than I remember it being. Can I bring this up in terms of quality? I feel like it stands out so much. And I wish my room was greener. You know, it could always be greener. That's what I always say. See, and it looks really green, too. I'll leave it like that because I think it's a better green, I think. I'll bring it up. I like colorful. You know, I need a second screen. I feel like it'd be so much better if I had a second screen. So, you have urea of ammonia. Is that ammonia? NH2? Is that ammonia? NH2. Azonide. Never mind. I'm an idiot and don't listen to what I'm saying. Which is widely used for fertilizer plastics and quite soluble in water. If you dissolve single urea, turn it in almost water. What vapor pressure solute? Okay, so let me show you guys something that I started using. That actually, I'll open it on my phone because I think it might be easier to like look at it on my phone. Oh, I open it here. This thing. Now, this thing is one of my favorite recent things that I've been using AI to do notes. So they're asking for atmospheric pressure, the vapor pressure of water. Pressure of solvent is equal to moles of solvent times pressure of solvent. So we have temperature change and we have pressure. We have grams of urea what is the vapor pressure of the solution at 24? What the hell? Oh, okay. And then here's what I like. For all the equations, can you also also add the name of the laws for equate I'm so tired. Anyways, while that's working on. So we know Raltoslavia pre. Raoult's law being a pressure P solvent is equal to X of solvent times P of solution, I think. So first we find the amount of moles. So we start with 8.65 grams of NH22CO. Grams of NH2, moles of this. And that is going to give us, so we have N2N4H 1C10. Oh, you know what? I'm gonna go hunting. I'm gonna go hunt this down. But it's here. Wait, I just realized you guys can't even hear the music. If I pause it, does it show up? No, wait, that's so sad. Wait, that's such a stupid. Wait, I just realized how dumb my bit was. If you guys weren't able to like hear the. Okay, regardless, it's too late now. Alright, I'm gonna go retrieve our periodic table. Periodic table freshly ripped out of my lab notebook. Okay, so nitrogen is 1401. Hydrogen is 1.08. Carbon okay, so altogether the atomic mass is 2.4 times 1.008 plus 12.01 plus 16.00. That's 60.062 per mole of whatever that is, right? Urea. So we have 8.65 divided by that, and it gives us 1 point. This is gonna look really weird because I ran out of space. 0.1444. Wait, what is the amount of water in moles? Oh, genius. Okay, so we now have the moles of urea, and now they're asking for the moles of water because we don't know the mole to mole ratio at all yet, right? So we need to figure that out. So in order to figure that out, we also need the moles of water. What are the two things they give us are 1.0 12.0 mLs of water and 1.0. So if we have 1.20 mLs of water and we have 1. And then we also have 1.00 grams per 1 ml. Cross that off. We have this many grams per ml. We also know that the formula for water is H2O. And then we have 2 H's, 1 oxygen, hydrogen being 1.008, oxygen being 16.00. So that gives us 1.008 plus 16.00. We have our final mass being 18.016. So then our mass of water and that gives us 1.20 times 1.00 divided by 18.016. That gives us a 1 point. Alright, if we do our moles, 0.0066. And because we're looking for the ratio as well, right? They're also going to tell us it's going to be moles of this. So, right, we have 0.144 moles over 0.0666 plus 0.144, and it gives us the ratio that we need in order to fulfill that equation, the vapor equation. So we have 1 point, and I'll even prove it to you, just in case I don't want to use any like wrong answers. That's what I did. 12.0 divided by 18.0. Oh, I put an extra decimal. I'm wrong. Okay, same thing, same concept. Yes. And now, what's the mole fraction? What did I tell you? What did I say? So we add 0.144 plus 0.666. So it's 0.144 divided by the combination of those two gives us a mole ratio of 0.177. And just to round up, right, we'll do 1.78. Oh, I'm stupid. Okay. Yeah. Technically 7. It's technically 7. .667. I just made a bunch of motherfuckers laugh right now. How do you get a completely different number? Sure. I don't get it, but sure. 0. get it, right? So we have pressure solvent. And then here we go. Vapor solvent. What is the vapor pressure of the solution at 24 degrees Celsius? So we have the vapor pressure of water. Okay, I'm gonna ask chat a very important question. I do want to clarify this. So the question I wanted to ask was basically in this.
¿Ha muerto qué?
As chat is figuring out right. Oh wait. One 822. Okay. I'm going to assume it's the only pressure they give us, so I'm assuming we're using that one. If we get 2.4 over 0.82. Right, chat? No, I'm wrong. We use the 0.822. This is giving me a headache. Like, it looks so simple when you, like, look at it. do it at home alone, you're like, oh, this is fucking stupid. I don't know what I'm doing. But I guess it makes sense in retrospect. So you have 0. 18.4. I think all of them like are like interactive, which I guess it makes sense. Okay, calculating the vapor pressure of a solution containing ionic solute. Predict the vapor pressure mixing 1.6 solid potassium nitrate with 1.77 grams of 25 degrees. The vapor pressure of the pure water is 25.80 grams. 80 grams. What are the moles of H2O? I'm gonna do straight lines next time. Just straight. Not a straight line, John. What the hell? But I'm so afraid to use space. I think that's the thing. So our first step would be moles of H2O. Guys, I really am so over this. I'll go to question 5 and then I'll take a... No. Fuck. I don't want to take a break, but I think I might have to. At 6, I'll take a break. Like a 5-10 minute break. Okay, step 1, moles of H2O. Right, so we're grams with, we have 1770 grams of (18.016 grams of H2O) in 1 mole. (177 divided by 18.016) equals 9.82 moles. And then next, nitrate. So we have 39.6 of sodium nitrate, and then we have another dimensional analysis, grams, moles, 1 mole. We have 1K, 1N3O. Ah! 39 plus. It feels like I'm doing math calculation in the middle of the forest, guys. It's so great. The solute is beforehand, so it's 0.392. Wait, hold up. Bro, you didn't even talk about this. What? Okay. Okay, hold up. Let me check the thing. Okay. So what I'm gonna ask chat now. Predicting the vapor pressure of a solution prepared by mixing. I'm actually crashing out. Let's see what chat has to say about it. Ah! I don't think I'm entertaining anymore. I think I'm just crashing out slowly. It's not doing it for me. let's see. Oddly specific ASMR. Where's the pumice stone? I don't like how that sounds.
Yes, exactly. How are you so good at coming up with those? And you're really good at giving pets the proper name. Like the fact that's what you named your dog. Get out of here. There is no way your dog would have had a different name. Like that is their name. It's so good. It was perfect. Aptly named. Amazing work. You are so good at that.
Guys, I think I might have to end stream for no particular reason. Anyways. Alright, What about how it's made? Is that on it? Well, that's not like good Mattel. What is Mattel? What the heck? I don't know. Listen to you guys. There's shuffle play right now. Do I not have this saved? What if I just look up ADHD? You guys feel focused? ADHD, go, go, go!
Sun's up. I come from science.
Oh, you know what I want to listen to? You guys are fucking hate this though. Wait, hold up. Hold the phone. Hold the phone. Here, I'm giving it to you. Hold the phone. Hold the teléfono. Just this. Ethereal background video. There we go. I'm back. I'm back, baby. I think every 5 minutes I have to mentally reset because then otherwise I'm like over this already. I want to get a new whiteboard. I was thinking of doing a thing where I just do it all on a whiteboard, like right here. The problem is I need one of those like roll-up whiteboards. I guess I don't. I guess I don't need that. Yeah, finish this question. I'll take a little bit of a break. I've been stalling for the last 5 minutes. For this one, count solute particles is not just formula units. Huh? What does it do with that? What the hell? I thought it was in the clear for that. So this is the one we're using. Okay, because in ionics, here's what I'm thinking. Like, I think this makes sense in lecture, not. Okay, I get it. Okay, so the equation we were using earlier is this one, is it? This was Raoult's law, which refers to a specifically a non-volatile non-electrolyte. It's not going to dissolve. Most non-electrolytes don't dissolve. That really depends, but most don't. And that gives us a really good basis for like being able to do this. If we, you don't see that. If we wait, I don't even know if I'm the right thing. We scroll down all the way here. The key aspect is Van Hoff's factor, or Van Hoff takes into account the dissociation of a strong electrolyte. Because it dissociates, you are going to have two different compounds in that like it's gonna dissociate, and most ionic solutes, ionic compounds, actually dissociate. That being said, it's moles of figuring out moles of solute, which I'm sure I have an equation, a practice problem that I did in class, I can't remember. Is MGC. Can you guys hear that? I feel like it's too loud. Oh, I think that is a bit too loud. guess not loud enough. Am I not quiet? Am I not loud enough for you guys? Okay, so in this specific example, why is it so bright? For example, we disassociated them, and then using the modal ratios, we found out what the solute is. I'm so tired. And I'm trying to get some support from identify the solvent, major component, dissolves into water, water solvents, and solute. Look at the solute type, strong electrolyte, multiply. Why do you... Wait, I'm trying to figure out. Okay, so based on my small bit of research, we know that sodium nitrate dissociates. It dissociates potassium nitrate. Potassium has a charge of 1, and this one has a charge of -1. Or NO3. It's a 1-to-1, which means that it'll still be the same. So we know that it has 0.392 moles. But I don't know what moles of what. I think that's what I'm trying to get confused by. Oh! Oh, I'm dumb! I'm dumb! Okay, so we have... Wait, we have moles of the whole thing. .932 divided by 2. 0. To find n particles, it's n solute particles. You do n particles and then you have to do I times n of KNO3. This is all together. And then how do you determine I? Great question. It's the wrong thing. How do you determine I? Let's see if it's on a cheat sheet. This is gonna be a really bad way of saying it. But I think it's been way too long trying to figure out what specifically any of this means. So moles of solute is equal to the moles of particles, which is I equals the moles of potassium nitrate, right? So then we now know moles to figure out the amount, the moles of particles, right? Or moles of particles in solute, moles of solute particles or whatever. You have to find I. Number of stuff. I think that's the only way I can like conceptualize it. I know there's an actual word for it, but that's the only way I can consider it because it's 2. So then in this situation, right, we have 3 times 2 times 0.392 moles should equal 0.784. There you go. And that should give us the answer. Did it take way too long to figure that out? Maybe. Mole fraction of water in solution. So now that we have the number of particles, oh my god, I'm so exhausted. Okay, predict the vapor pressure of the solution predicted by solution prepared by mixing 3 point. The mole fraction of the solution. Okay, so we have this represents the number of ion particles total in the solution we have. So in order to figure out how much, hold on, give me a sec. In order to figure out how much water is in it, we take the moles of water of 82 over moles of water of 982 plus, right, because we still have the ions in there, plus the ions 0.789. And that should give us, oh, actually, I should move this around. Oh, wait, they don't have a lasso tool? That's actually sucky. Anyways, we'll erase this somewhere else. It's not math, it's chemistry. So for step 3, we find water in solution. So we have, oh my god, that solution. Lose my train of thought. Okay, so then back to, I started 9.8. 9.82 moles of water times 9.82 moles plus 0.392 moles. So, that being said, we have 9.82 plus 0.392, and then we have that 9.82 divided by this, which gives us 0.962. No! Thought I had it. Oh, I used the wrong number. Too many guys must have been tweaking out about that. 7, 8, 4. Because we're counting the amount of ions. The vapor pressure. So now we have the moles of water in solution. And we determined vapor pressure. Right? Same way we did before. We multiply the moles. 26 times the pressure that we're at, so it's 23.76. That should give us a pressure of 22.0. Let's take a look. Look at that. Look at that. Okay, so I'm gonna take a quick, let's say 10-minute break. I'll be doing it for another. Hey Alexa, turn off my alarm.
6:35 p.m. alarm canceled.
Hey Alexa, turn on an alarm for
Alarm for what time?
7 p.m.
Alarm set for 7 p.m.
Can I add a? Wait, let's see. Can I add a trigger? I think yeah, the audio is fine. I think I might have to put it down. I could not figure that out. Is that one audio where it's like, I never got over the language barrier? I will be back. What if I do, if I do this?
Give me many gifts. And by that I mean introduce me to many things.
Let's do 10.
Worlds I had no idea existed.
This seems might seem really ghetto,
The sweeter side
but
of the
it'll work, I guess.
And one that I never knew was there.
Just don't drop.
And also what's darker skin. That even with that
I might come a bit
darker
early.
part of it on me,
I don't know. We'll see.
being with me. In the end, I need you. And you don't need a girl as a person. Everything that I am today came from you.
back. Hold up. Okay. So, also if I'm back again tomorrow, if I stream again tomorrow, and I'm wearing the same sweater that I'm wearing now. I'm not wearing the same sweater I'm wearing now. You're imagining things, and I think you're being crazy, and you're just like your mother. You know, it's unfortunate. You know, sometimes people just go through their stuff, and yeah. So I will not be wearing the same exact sweater, and if I am, you didn't see it. Stacy, what's up? You wanna come on? Come on. So, here, I have a special guest! Yes! We got one! I'm gonna have to say hi to the camera. I always forget which direction I have to go. Look at the camera! There, I knew you one better. Hold up. Oh, you can't even see her. Wait. Streaming dog. Hey yo. Stacy, come on. Okay, you want me to sit down? Is it better for it to be a little lower? I feel like it isn't, but I can't tell. This music is really ethereal for... Oh, she wants to get out. Never mind. What? If Stacy, if you want to sit with me, you can sit with me, but I'm not taking you for what. I think my favorite thing so far about what I've learned is how little actual content comes from, like, the fact I'm streaming right now. And, you know, it is what it is. Okay, so we're back at it again. We're continuing. My internet likes to connect to. Okay, so while that's happening, wait a minute. I don't know why it's taking so long to load. Okay, there we go. And it should load. There we go. Damn, somebody has their fridge connected? That is crazy. I would have never expected the fridge to be a part of it. So I want to see what actual information we have here. Because it's two solutions, and I'm curious if we looked at that before. Or at least the information behind it. Is it the same for colloids? Is that what it is? Okay, I think similarly, it depends on whether or not it's a non-electrolyte or electrolyte. I think these are gonna dissociate. So we need grams, we need vapor pressure. Pentane, molar mass of this, and hexane, molar mass of this, form a ideal solution. What does it mean by ideal solution? Rhodes law directly. Okay, so Rhodes law, the same one we used for, I believe it was this one. Yeah. We found the mole of both of them, and we found the mole to mole ratio. Let's start with that. Yeah? There you go. So we have moles of things. So we have C5H2. More specifically, we have. Oh, yeah. We have 17.3 grams of pentane, which is C5H12. And we have. So I'll do the mole to mole for that one first. We have 72.146 grams per mole. And then we have 38.6 grams of hexane, or better known as 6. Which should give us. I wanna like scratch my nose enough for people to assume I have like a fucking rug problem or something. Actually, I don't want that. Don't think that, guys. I thought it'd be a really funny concept, but then I'm like, I don't want my job to think that I do crack or something, so I'm gonna not wish that upon myself. I pulled up my phone as a calculator. What am I doing? So we have 17. In retrospect, next to my phone, I think the screen on this feels so weird. 0.3 divided by. Oh, we find a mole fraction for both of them. Oh, I feel like I'm not talking too much. Okay, so I was like logging in. So now that we have our mole ratios, right? We find the mole fraction for both of them, right? So we basically just invert over 0.240 plus 0.448. And then do 0.240 plus 0.8. And then 0.240 348 divided by. And that gives us 0.349. And then this gives us 0.651. I didn't even do like a sound check or anything. Wait, but then what is the pressure though? Do they each have their individual pressures? So what I asked chat right now is that if I just add the pressures together, because we can, if there would be no reason if they didn't. Ideal solution with two volatile liquids, each compound contributes on partial pressure. Yeah, that makes sense. Okay, yeah. I was like, there's no way they're asking me to look for it and then not like kind of do the thing. So that being said, we have our mole fraction of both, and then we have a pentane. Pentane is the C5. So pentane, and then this one's times 511 tor. This one's times 150 tor. And that gives us P. So you have 0.348 times 511. And then we have times 150. 178.255. .97.7. Yeah, 275. Look at that. So we added these, and I get 275 point. I guess 276.0 or 275. Either one, because the reason I say 275 is because I got 275.90, but I also realized that I put in straight through the calculator, so I should have like rounded at some point. I always have to open it to like be able to make sure you guys can see. Like, copied it directly. You briefly saw that. We can probably do one more. Oh, fuck. Wait, I think I might be able to just do this. Okay, click on the point of the curve that shows the normal boiling point of water. Okay. I'll do a different question, actually. Is there an easy question I can just guess? Okay, so I think this is where I call it. I have been streaming for a while now. Why does it do that? Alright. There we go. Or the bit rates is really bad. Okay, so this is it, I guess. That's pretty much it. I've been streaming for a while now. I want to say several hours. I will try to be uploading the stream so people can watch it, so that I can watch it. Hold up. I got it now. I will definitely be trying to do this more often. I will try to be back tomorrow. Let me know what vibes you guys want. Let's hope there's more traction to this. I really want to do this regularly, and I think it'd be really good for people to like have reference for that. Yeah, thank you guys. Like, communication is something really big, and I'm really happy about it.